students, welcome back to Diksha Vedantu English channel. This is Suhas, your chemistry master teacher. Students, in this video, we discuss real numbers in 20 minutes. Students, we know from this unit we can expect 6 to 8 marks, minimum 6 marks. Students, please watch the video till end to ensure to score 6 marks. Students, let's discuss. Come on, let's discuss. These are the topics present in the real numbers. First one, very important, the fundamental theorem, very important, 2 marks. Definitely they ask the definition, right students, and also LCM and HCF and revising irrational numbers, about the problems. Come on, let's discuss. Before entering the class, please do not forget to like, share, subscribe the channel, and also Telegram channel. The Telegram channel link is there in description. Let's move. What is prime factorization? Before entering to the theorem, prime factorization is very important. What is prime factorization of any positive integer? Say 60. How to find out prime factorization? Let's say 60 number. Here students, prime factorization of 60. 60. First, let's try with 2. Prime factorization or prime tree is nothing but division tree. Division, we are already famous, right? 60 is divided by 2 into 30, then 30, 2 into 15, then 3 into 5. This is called prime tree. This is called tree. In tree, many branches is there, na? Same, these are called as branches. Okay, finally, how can we write like this, student? 60. Here, 2 into 2, then into 3 into 5. Right, students? We can write like this. 2 into 2, 3 into 5. 2, it is there in 2, right? 2 into 2 is nothing but we can write like this. 2 power 2, 3 power 1 into 5 power 1. Totally, this is an prime factorization of 60. Very important, students. If you know this prime factor tree, you can easily solve the LCM and HCF problem. Let's move. This is called prime factorization of any positive integer. Here, look here. It is have some value. Consider any positive integer, students. For example, consider 30 value. 30 is become, what is the prime tree of 30? 2 into 15, 3 into 5, right? It is like 2 power 1, 3 power 1 into 5 power 1. For any positive integer, prime factorization is always unique. This is called fundamental theorem. This is called, what is this called? Fundamental theorem of arithmetic. It is very important. Please take a screenshot, or if you want these notes, if you want this PPT, I upload in description. Please download it. The prime factorization of any prime integer is unique. First important point. Second one, that is nothing but every composite number can be factorized as a product of primes. Primes is nothing but in tree we have so many branches, right? That is called as an primes. Okay, students, and this factorization is unique apart in the order which the prime factors occur. Very important. Okay, students, come on, let's solve some problem. First one, explain why is a composite number. We need to find out the composite number. What is composite number? If the number has more than 2 primes, expect 1 and itself. Okay, now I understood, students. Expect 1 and itself. It has more prime numbers. Otherwise, it have more prime factorization. That numbers are called composite numbers. Come on, let's find out. Let's choose I. Let's choose this equation as an I. Okay, I or star, anything. If you want anything, you can choose. Students, in maths, very important. Please write or please solve the problem by step. Every step have an marks. For this step, we have an off marks. Right, students? Very important. Then here, look here. Overall equation 11 is common, right? 11 is common. If we take 11 common, what happened? 7 into 13 plus 1. 7 into 13 plus 1. We can write like this, right, students? We can write like this. 77 plus 1, that is nothing but 78. How can we write 78? What is the prime t of 78? 13 6. 13 6, 6 into 1. This is an prime t. Right, students? And here also 6 we can write like this. 2 into 3. This is an prime t. Finally, we write like this. For this number, I is divisible by 2 as well as 3 and also 13. Right, students? 2 and 3 and 13 is nothing but it has more than 2 prime factor. That's why this number is called as a composite number. What are composite number is nothing but if the numbers having more than 2 prime factors. Now, these numbers are called as a composite number. Please note down this point. Next, it's some quiz time is there, students. In this unit, minimum 2 MCQ is coming for your board exam. That's why quiz time is here also in exam. In marathon also we discuss more quiz. Okay, students, first question. 225 can be expressed as, we have 4 options. Come on, let's find out fastly. 225. First start with 2. 2 is nothing but it's not happen. Next 3. 3 to 25. Students, fast. 3 7s are 21. 3 5s are 3 into 75. What's about 3? 3 2s are 6. 3 5s are 25. 3 into 25, 5 into 5 is nothing but 3 power 2, 5 power 2. Where is there? Option C is an correct answer. Let's move for the second one. It's a CBSE 2021 question. The number 385 can be expressed as the product of prime factor. This is an Homer question. We have 4 options. 5, 11, 13, B, 5, 7, 11, 5 into 7 into 13, 5 into 11 into 17. This is an Homer answer. I don't show the answer for this question. Next, move for the HCF part. What is HCF? I common factor, right, students? But here the HCF pattern is different. We get the final number as a same number only. Final, if you find the HCF in different, we have different manner is there, highest common factor, many thing is there, many procedure is there. If you find using any procedure, the HCF values must and should be same. But come on, let's find the prime factorization. Why here, sir? Why, Suhas sir? We have many methods. Why you use prime factorization? Why? Because by using prime factorization, we can easily find out the value. Come on, let's discuss. Let's find the HCF of 54, 72 and using prime factorization. First, we need to write the prime T for 54 and 72. Let's start with 2. 2 2s are 4, 27, right? 3 9s are 3 3s are. What is the prime factorization of 54? Here 2 only is present in only 1, 2 power 1, 3 power 3. This is an prime factorization. In case of 72, what is the prime factorization, students? 2 3s are 6, 36. 2 18s are. Then 2 9s are. Then 3 3s are. What is the prime factorization of 72? The prime factorization of 72 is 1, 2, 3. 3 2s are there, 2 power 3 into 3 power 2. Look here, these are the prime factorization. Here we need to find out the HCF. For HCF, for finding the HCF, we have some methods. First, we need to find out the prime factor, prime tree. And next step, we need to consider the highest common factor present in both one. Okay, here only 2 power 1 is there, but here 2 power 3 is there. That's why we need to take only 2 power 1. 2 power 1 is present in this also. We can write 2 power 3 as in 2 power 2 into 2 power 1, right? In both prime factorization of 54 and 72 prime tree, only 2 power 1 is there. In here 3 power 2 is there, but here 3 power 3 is there. 2 power 1 into 3 power 2. I repeat once again how to find out HCF. First, we need to find out the prime factorization, prime tree. Then, we need to take the highest common factor present in the primes. Highest common prime present in the prime factor. Here, look here. Both. We need to consider both. If instead of 2 power 1, if it's 2 power 3, here 2 power 2 is there now. We need to consider as in 2 power 2. Finally, the answer become 2 power 1, 2. 3 3s are 9. It's become 18. 18 is the HCF of 54 and 72 by using this. Okay. Yes, 18. Then next question, students. Okay, yes, it's done. Next question, 140, 210 and 300. Come on, let's find out first. 140, 210 and 300. Yes, students, 140, 210 and 300. Okay. Prime tree, 2 into 7. 2 7 the 40, 70. Right, student? 270 is a 140. 235 is a. Then 4 is not divided by 3 into 35. No, 3 in also not divided by. Next, 5 7, the 7 5 the 35. 5 7. This is a prime tree for 140. 5 power 1, 7 power 1. In the case of 210, 2 into 105, it is divided by 2. No, 5 is there in last number, it is not divided by 2. Then move for the 3. 3 3s are 9. 3 3s are 9 and 3 5s are 35. 3 35s are. And same, 5 7. It's nothing but 2 power 1, 3 power 1, 5 power 1 and 7 power 1. Last one, 300. 2 into 150. 2 into 150 it's done now. 2 into 75. Then 75. 3 it is 3 it is divided by 3. 3 into 3 2s are 6. 3 2s are 6 and 23. 23 is done. 23. What is the 23 prime factor here? Look here. What is the 23 prime factor, students? 2 150 done. 275 is a 150. 323 is a. No. 25 here, like students. 3 5s are 15. 25. 5 5s are. Here, what is the 2 power 2, 3 power 1, 5 power 5? What is HCF? Look here. In 2 power 2 is there, but here 2 power 1 is there. It's nothing but 2 only. Next here, 3 is not there. That's why 3 get cancelled. Compared to 5 is there, 5 power 1 is there, 7 is also not there. The HCF value is 10. I hope it's clear. Let's move for the LCM. HCF and LCM both are same, both are procedure is same, but different, sorry. LCM is different, HCF is different. LCM is nothing but least common multiply, right? HCF, highest common factor. But what now, students? Procedure is same. We need to find out the highest, no, sorry. We need to find out the prime factor. Then for LCM, we need to consider the highest common, not an highest common factor. In any one number, 2 power 3 is there, na, I number is there, na, we need to take the I prime number in any three numbers. Okay, let's find out. 140, 210, 300. We already find out, right? These are the 2 power 2, this is there. If we find out HCF now, if we find out HCF, here, look here. 2 power 1 is present in this one, that's why 2. Then what's about 3 is not present, 5 is present, 7 is not present. Then HCF is 10, but LCM, here, look here. 2 power 2 is highest number, we need to consider that one. And also, here 3 power 1 is there, we need to consider 3 power 1, 5 power 7, 7, totally 2100. This is a difference between LCM and HCF. This is the procedure. Please take a screenshot, okay? Please take a screenshot. Either I post the notes in description, please download it. Write all prime factor, then take highest powers of all primes, multiply them to get LCM. Here, write all common factor, take least powers of all primes. Least power is nothing but in all primes, all prime factorization, all prime t, the primes must and should be present, and multiply them, get to HCF. Very simple. Then next, consider next important learning outcomes. Next, find the relation between LCM and HCF. Okay, students, let's take two example. Here 50 number is there. 50 number is there. How to write the prime factor t? 3 into 5, right, students? This is an prime factor. Finally, we can write like this. Okay, students, 15. Then 24. For 24, this is an prime factor. What is the LCM value here, students? LCM, HCF. LCM is equal to, what is the highest factor? Here 3 power. Okay, 3 into 2 power 3. 2 2s are 4, 4 2s are 8, 3 2s are 24. LCM is 24. What's about HCF? HCF only 3. HCF is 3. This is 24. Okay, students, this is a relation. HCF into LCM is equal to the product of the two numbers. What the numbers we find out now? That is equal to LCM into HCF. Here, this is A into B is equal to HCF into LCM. And also one important point is there. Relation is applicable only for two positive integers. Okay, let's find out the first question. Find the HCF and LCM of number 6, 8, 12, and hence check whether it's not or at. Okay, 6, 8 to 12. Here 2 3s are, 2 4s are, 2 2s are, 2 6 are, 2 3s are. What is the HCF here, students? Here everywhere 2 power 1 is there, 2, 3 is not there. HCF is 2. What about LCM? What is LCM, students? Here highest factor is 2 power 3, 2 power 3 into what's about, where is there that one? S. 3 power 1 is an highest factor. 2 power 3, 2 2s are 4, 4 2s are 8, 8 3s are 24. 24 into 3 is nothing but 48. What's about 6 into 8? 6 into 8 is nothing but 48 into 12. It is not proved that. We already know, right? It is only applicable for two numbers. That's why it's not proved that. Quiz time, student. First question. If HCF is equal to this one and LCM is what? Here, just look here. 39 into 31, that is equal to 13 into x. If you find out that, you got the answer. CBSE 2021, very important. The answer is 273. Okay, next, by using fundamental theorem, next application, students, we can determine the unit place at a given number. Unit place, we can easily unit place. For that, one question is there, prove that number 6 power n does not end with the digit 0. Okay, which number is end with digits, students? We can consider like this. For example, some example you take this 7, 7, this one. If it's end with 0, it's nothing but definitely it must multiply by 10 only, right, students? We can write like this. 10 is nothing but 2 into 5. We can write 6 also. Otherwise, in the place of 6, we can write 2 into 3 also, right, students? Here, look here, it's nothing but the number end with the 0. Its prime factorization must then contain both 2 and 5. But here, question what is there? 6 power n is there. That's why it's not considered. Prime factorization of 6 power n contains 2 but not n 5. 6 power n is nothing but 2 power n into 3 power n, right, students? That is nothing but it's not contained. Okay, next, theorem 2, very, very important. What is the statement of theorem? Let P be a prime number and A is a positive integer. If P divides A square, then P divides A. We need to prove that P divides A square. Someone is dividing something. Okay, 2 is divided by 4. Then we need to prove that 4 is divided by 2. Right, students? S. No. 2 is divided by 4. We need to prove that 2 is divided by 2. This thing. For this, we already know, right? Very important. Please buy this theorem. It's very important for your board exam. From the fundamental theorem, how to write that? arithmetic integer can be factorized the product of primes. We know, right, from the fundamental theorem, the prime factorization, the arithmetic progression or the arithmetic integer we can write by the product of primes. Let's choose some prime factorization of A where P1, these are the primes, not necessarily distinct. Right, students? Then now we already know, right, factorization the product of primes we already know. Then this A, what about A? A, it becomes, this is A, what about A square? A square is nothing but we need to multiply both numbers. If we multiply, we got this. Okay, students? Then by using these, how to write, like we already get this A square value. It is given that P is prime and divided by A square. P is some prime value, it is divided by A square. Therefore, P is a prime factor of A square from the uniqueness part of the fundamental from these students, P1, P2. Therefore, P is one something. Theorem of arithmetic, it follows that the only prime factor of A square or P. This implies that this one. I hope it's clear. Okay, students, very important, just buy it. Next question, if n is any natural number, then 12 power n cannot end with a digit. 2 is there, 8 is there, 4 is there, 3 is there. 2 per 12, it's never end with 0, right? Sorry, it ends with 0. Why? Because here, look here, 12 power n, how to write like 12 power n? 12 into 3 into 1. We already know 0 always ends with 0, always ends with 2 into 3, 2 into 5. If we present 2 into 5 now, we can easily tell like that. 2 as well as 5 in its prime factors. 12, we can write like the students, 12, 2 into 5 into another 2. 2 twos are, yes, 12. 2 into 6, 6 into 3 into 2, right, students, where at least single multiply of 5 prime factor. So 12 cannot end with the digit 0 or 5. That is, the question is cannot end with, the answer is 0, correct, right? As 0. Why? Because 2 into 5 is must and should be there. Rational number, very important, last concept, student, number of P by Q. What is rational number? The number of the P by Q format is called rational number, where Q is not equal to, must and should be, Q is not equal to 0. If it's equal to 0, it becomes infinity, right, student? These are the rational number. From using fundamental theorem, we can easily find out the decimal representation of rational numbers is either terminating. Terminating is nothing but, for example, what is the value of 1 by 2? 0.5. This is called terminating, only single value. Recurring is nothing but for 4 to 5 number, it becomes terminate. Non-terminate is nothing but, for example, 1 by 3. What is the value of 1 by 3? 3, 1, 0. 3 3s are 9. 0.33333 is going na. This is called non-terminating. I hope it's clear. Okay, let's find out the value. 0.5, 0.33. Let's write. From using this, one important question is there. Just look here. For what denominators of the decimal expansion is terminate? This one is right, 2 and 5. Just look here. If 2 is present, if 5 is present, in exam, definitely from this part, one MCQ question they ask. How they ask? Because they give some numbers. In which number that prime factor is terminate and other thing they ask. Very important. Okay, for example, let's look here. We can write this 20 as in 2 power 5. It's nothing but this is an even terminate value, right, students? 1.625 is there, 0.556 is there, this one is there. From using this, we can easily tell like that. If the denominator contain 2 into 5, we can tell like that. Here one important is there, where the denominator is of the form 2 power m, 5 power n, where m and n are whole numbers, then the decimal expansion is terminating. It should be whole number also. Okay, students, I hope it's clear. Quiz time. First question, it's on CBSE 2021 question, students. The question is 4.57 is an integer, rational number, irrational number, natural number. The answer is rational number. This one is 4.57. Okay, why? Because, okay, students, this one is on the top. On is a non-terminating and recurring decimal, and it is a rational number. The decimal expansion of this one, it is an CBSE 2021 question. We have 4 options. A is terminating, B is non-terminating, and none of these, and is non-terminating and recurring. This is an homework question. Just tell the answer in that one. Okay, next look an interesting property here. We can write this one 32. We can write like 2.4. Students, here look here. How many m, for example, 2 power m is there now? How many m digits or how many m is there now? If m is equal to 4, then we have 4 digits. For example, this one, there are 4 4s, that's why this happens. And for example, it's nothing but there are 4 decimal digits. For example, here 2 is there, it's like this, 2 power m, 5 power m na. If it's present in m, for example, m is equal to 4 is there, it is there in 4 digits. This thing is happened. Okay, students, I hope it's clear. This is only applicable for 2 into 5. Number of decimal digits is equal to number of 2s or number of 5s, which is greater. That's all. Let's solve some question. First question. Of the rational number 13 by 8, 12 by 20, 7 by 15 and 23 by 25, which one does not have a terminating decimal explanation? We can expand the decimal. Here 2 power 3 is there. Yes, it is there. Terminating, haven't, not haven't, terminating is nothing but non-terminating. This one has a non-terminating. Here look here, 2 is there, 2 is there, 5 is nothing but 2, 5 is there now. It is terminating, but it is not a non-terminating. I hope it's clear. Quiz time. First question. That decimal expansion of rational number will terminate after 1 decimal or 2 decimal or 4 or this one. If we expand this 250, we can get 2 into 5 power 3. 3 is there now. 3 is nothing but it 3 values is there. 3 number is there, right? 3 digit values is there after 0. We can tell like that 3 decimal place. It is about the real number. If you have any doubt, let us know in comment section. And also please do not forget to attend the homework question answering comment. And also every video is there in 30 minutes, students. Please watch it. Please watch it. Okay. And also bye. Take care. All the best for your maths exam.